In question number 17, it is given that a toy is in the form of a cone of radius 3.5 cm mounted on a hemisphere of same radius. The total height of the toy is 15.5 cm. Find the total surface area of the toy. This is the toy. Here radius is 3.5 cm and total height is 15.5 cm. We have to find the total surface area. Here total surface area of the toy will be curved surface area of the cone plus curved surface area of the hemisphere. Now in case of hemispherical part, radius is 3.5 cm. In case of conical part, radius will be same, it will be 3.5 cm and height will be 15.5 minus 3.5, that will give 12 cm. Since we have to find the curved surface area of the cone, so we require slant height. For slant height, we have to use this formula L equal to root over h square plus r square. So 3.5 square plus 12 square. From here to here it is 12. So 3.5 square plus 12 square. 3.5 square is 12.25 plus 12 square is 144. If I add, it will be 156.25. Now we have to find the square root of 156.25. We have to pair like this from decimal. One pair is like this. This is another pair. 1 is left. Now 1 1 ja 1. 56 is left. Now double of 1 is 2. 22 2 ja 44. So it will be 56 minus 44, 12. From here 25 will come, so it is 1225. Now if you take the double of 12, it will be 24. 245 into 5 will give 1225. So square root of this will be 12.5 centimeters. Now total surface area of the toy will be curved surface area of the cone plus curved surface area of the hemisphere. For cone, formula is pi RL, and for the hemisphere it is 2 pi r square. From here if I take pi r common, we are left with L plus twice r. Pi is 22 by 7 into radius is 3.5. L is 12.5 plus twice r 2 into 3.5. Now 7 and 3.5. 3.5 2 ja 7, so it will be 22 by 2. Again 22 can be cancelled by 2, it will be 11. From here 12.5 plus 3.5 into 2, 7. So it is 11 into 19.5. 12.5 plus 7 is 19.5. 19.5 into 11 will give 214.5. So 214.5 centimeter square is the total surface area of the toy. Question number 18. A cylindrical vessel with internal diameter 10 centimeter and height 10.5 centimeter is full of water. A right circular cone of height 6 centimeter and radius 3.5 centimeter is immersed completely into the vessel. Find the volume of the water displaced out of the cylinder and left in the cylinder. So this is the cylinder whose diameter is 10 centimeter and height is 10.5 centimeter. Now this cylinder is full of water. Now we have immersed one cone whose radius is 3.5 centimeter and height is 6 centimeter. We have to find how much water will be displaced and how much water is left. Now in case of cylinder, diameter is 10, so radius will be half of it, it is 5 centimeter and height is 10.5 centimeter. In case of cone, radius is 3.5 centimeter and height is 6 centimeter. Here we can consider radius to be R1 and H1. Now in case of cylinder, volume of water is pi r square h. So pi is 22 by 7, r square 5 into 5 into 10.5. 7 and 10.5 can be cancelled. It will give 1.5. So 22 into 5 5 ja 25 into 1.5. If I multiply this, I am going to get 825 centimeter cube. Therefore, volume of water in the cylinder is 825. Now, how much water is displaced? Whatever is the volume of the cone, that much water will be displaced. So, volume of water displaced out of the cylinder is equal to the volume of the cone. Volume of the cone is 1 by 3 pi r1 square into h1. Since we have considered cone's radius is r1 and height is h1. So 1 by 3, 22 by 7, 3.5 into 3.5 into 6, 3.5 2 ja 7, 2 11 ja 22, and this 3 and 6 also can be cancelled. So we are left with 11 into 3.5 into 2. After multiplying, it will be 77 centimeter cube. Therefore, volume of water displaced will be 77 centimeter cube. Now we have to find volume of water left in the cylinder. It will be volume of cylinder minus volume of the cone. Volume of cylinder we got 825 and cone it is 77. If I subtract, it will be 748 centimeter cube. So this is the volume of water left in the cylinder. So the final answer is volume of water displaced out of the cylinder is 77 centimeter cube and volume of water left in the cylinder is 748 centimeter cube. As question number 19 is not so important for exam purpose, I am showing question number 20. A toy is in the form of a hemisphere surmounted by a right circular cone of the same base radius as that of the hemisphere. If the radius of the base of the cone is 21 centimeter and its volume is 2/3 of the volume of the hemisphere, calculate the height of the cone and surface area of the toy. Suppose this is the cone and this is the hemisphere. It is given they are having the same radius and here radius is 21 centimeter. Height of the cone is not given, so we can write in case of hemisphere radius is 21 centimeter. In case of cone, radius is 21 centimeter but height is not known. As per the question, volume of the cone is 2/3 of the volume of the hemisphere. We know the volume of the cone is 1/3 pi r square h equals to 2/3. Volume of hemisphere is 2/3 pi r cube. So 1/3 pi r square is equal to 2 2 is 4, 3 3 is 9 pi r cube. Therefore, height equals to 4/9 pi r cube by 1/3 pi r cube. Now if I divide, then this 3 and 9 will cancel. It will be 3. This pi and pi can be cancelled. So we are left with 4/3 r cube into 1 by r square. Now r cube and r square also can be cancelled. We are left with 4/3 r. So 4/3 r. Radius is given in the question 21. 21 can be cancelled by 3. It will be 7. 4 7 is 28. Therefore height of the cone is 28 centimeter. Therefore we got height of the cone is 28 centimeter. Now we have to find the surface area of the toy. To find the surface area of the conical part, we require slant height. So first of all, we will calculate the slant height. Then we will calculate the surface area of the toy. Now if I consider L centimeter with the slant height of the cone, then L will be root over h square plus r square. H is 28. So it will be 28 square plus 21 square. 28 square is 784. 21 square is 441. After adding, it will give 1225. If you take the square root of 1225, then it will be 35 centimeter. Now we have to find the surface area of the toy. That means curved surface area of the conical part plus curved surface area of the hemispherical part. For conical part, it is pi r L. For hemisphere, it is 2 pi r square. From these two, pi r can be taken common. We are left with L plus twice of r. Pi is 22/7 into 21. L is 35, which is the slant height, plus twice r, 2 into 21. 22, 21 and 7 can be cancelled. It will be 3. 35 plus this and this, if I multiply, it will be 42. So 66 into, after adding, it will be 77. If I multiply, it will give 5082 centimeter square. Therefore, surface area of the toy is 5082 centimeter square and the height of the cone is 28 centimeters. Question number 21. It is given that a solid is in the shape of a cone surmounted on a hemisphere, the radius of each of them being 3.5 centimeter and the total height of the solid is 9.5 centimeter. Find the volume of the solid. So in this case, total height is 9.5 centimeter and radius is 3.5. So in case of hemispherical part, radius is 3.5 centimeter. In case of conical part, radius is 3.5 and height will be 9.5 minus 3.5, which will give 6 centimeter. Since we have to calculate the total volume, it will be volume of the cone plus volume of hemisphere. We know volume of the cone is 1/3 pi r square each and volume of hemisphere is 2/3 pi r cube. From here I can take 1/3 pi r square common. From here h left and from here twice r left. So 1/3 pi is 22/7 into r square. R is 3.5. 3.5 into 3.5. Height is 6 plus twice r, 2 into 3.5. Now 7 can be cancelled by 3.5. It will be 2. So 1/3 into 22/2 into 3.5. 6 plus 3.5 into 2, 7. Now 22 and 2 can be cancelled. It will be 11. So we are left with 11 into 3.5 within bracket 6 plus 7 divided by 3. So 11, 3.5 into 13 is 45.5 by 3. If you multiply these two, it will be 500.5 by 3, which will give 166.833. After rounding, it will become 166.83 centimeter cube. Therefore, volume of the toy is 166.83 centimeter cube. In question number 22, it is given a wooden toy is made by scooping out a hemisphere of same radius from each end of a solid cylinder. If the height of the cylinder is 10 cm and its base is of radius 3.5 cm, find the volume of the wood. Here it is given that in case of hemisphere, radius is 3.5. In case of the cylindrical part, radius is 3.5 and height is 10 cm. We have to find the volume of wood used. Here it will be volume of the cylinder minus volume of this hemisphere and the lower hemisphere. So we can write volume of the wood in the toy. It will be volume of the cylinder minus 2 into volume of hemisphere. Volume of cylinder is pi r square each minus 2. Volume of hemisphere is 2 by 3 pi r cube. From this 2 I can take pi r square common. H minus 4 by 3 r. Pi is 22 by 7 into r square. Radius is 3.5. So it will be 3.5 into 3.5. Height is 10 minus 4 by 3 into 3.5. Now 3.5 to the 7. So it will be 22 by 2 into 3.5. 10 minus 4 into 3.5 will be 14. 14 by 3. Now 22 and 2 can be cancelled. It will be 11. 11 into 3.5. Here 3 LCM. 30 minus 14, 11 into 3.5 into 30 minus 14 is 16 by 3. 11 into 3.5 into 16 is 56 by 3. If you multiply, it will be 616 divided by 3, which will give 205.33 centimeter cube. Therefore, volume of wood in the toy is 205.33 centimeter cube. Question number 23. The largest possible sphere is carved out of a wooden solid cube of side 7 cm. Find the volume of the wood left. Now here in case of cube, each side is 7 cm, and in case of largest sphere, diameter will be 7. Since diameter will be 7, so radius will be 7 by 2. So volume of wood left will be volume of cube minus volume of sphere. Volume of cube is side cube. It will be a cube minus 4 by 3 pi r cube. This is the volume of a sphere. A cube is 7 cube minus 4 by 3, pi is 22 by 7, radius is 7 by 2 into 7 by 2 into 7 by 2 because it is r cube. So 7 cube minus, here 7 and 7 can be cancelled, 2 and 2 4, these 4 can be cancelled, 2 11 to 22, so we are left with 11 into 7 square by 3. From here 7 square can be taken common, we are left with 7 minus 11 by 3, 7 square is 49, from here 3 LCM. 3 7 is 21 minus 3 divided by 3 1 into 11 11, 49 into 10 by 3 490, 49 into 10 is 490 by 3, which will give 163.33 centimeter cube. Therefore volume of wood left is 163.33 centimeter cube. Question number 24, it is given the largest cone is carved out from one face of solid cube of side 21 centimeter. Find the volume of the remaining solid. Now this is the cube from which one cone is removed. So in case of cube, each side is 21 centimeter. In case of cone, diameter is 21. So radius will be 21 by 2 and height will be 21. We have to find the volume of the remaining solid. It will be volume of cube minus volume of cone. Now volume of cube is side cube minus volume of cone is 1 by 3 pi r square each. So 21 cube minus 1 by 3, pi is 22 by 7 into r square. R is 21 by 2 into 21 by 2, height is 21. 2 11 is 22, 7 and 21 can be cancelled, 3 is left. These 3 and these 3 also can be cancelled. So we are left with 21 cube minus 11 into 21 square by 2. From here 21 square common. So we are left with 21 minus 11 by 2. So 21 square is 441, 2 LCM, 42 minus 11, 441 into 31 by 2. If I multiply, it will be 441 into 31 will give 13671 divided by 2, which will give 6835.5 centimeter cube. Therefore, volume of the remaining solid is 6835.5 centimeter cube. And question number 25 is same as question number 15. So I am not showing, and that's the end of 13A. In my next video, I am going to start from 13B. Till then, bye bye, take care, and wait for the next part.